Hey everybody, Brian Fehrman here, and welcome to this week's episode of AI Security Ops. Now you may observe that it's just me this week, and that is because during this recording, the rest of our crew was out at Wild West Hackin' Fest, which is the annual conference put on in Deadwood, South Dakota by Black Hills Information Security, which is a great segue into the promo for the episode, which is this episode is brought to you by Black Hills Information Security. So if you are in need of security testing for your organization, whether that is AI specific or web apps, network test, mobile applications, physical test, social engineering, whatever you might need, we likely provide that service. So come check us out at blackhillsinfosec.com. This episode is also brought to you by Anti-Siphon Training. If you are in need of some security training at a very good value, but without sacrificing quality, come check us out. These courses are put on by mostly our pen testers, and so people who are in the trenches day in and day out, who are just wanting to share with you the information and the techniques and tips that they learn throughout their daily process. Check out Anti-Siphon Training for some of the cool training courses that we have out there. So with that out of the way, let's jump into the episode for today, which is on model extraction attacks, when hackers steal your AI. So imagine this scenario. You as a company have just trained your multi-million-dollar model. You spent millions upon millions of dollars and probably months upon months of training your large language model or other AI system that you have, and you've got it out there, and now someone has figured out a way to steal it. But they didn't steal it by breaking into your environment and pulling out the files that are associated with your large language model. Instead, they stole it just by interacting with it. How is that possible? Do you think that that's an academic exercise or something that someone could actually do? Well, it is very real, and it's what's known as a model extraction attack. And there is actual speculation on that the DeepSeek model was created using this method by essentially querying OpenAI's models numerous times, many times, and using the information that they would get out from the queries to then go and train their own models. So what exactly is a model extraction attack? Well, basically the idea is that you have somebody who has gone through the very expensive and laborious process of training their own model from scratch. When it comes to training a model, there are a lot of facets that are involved in this. You have to start with data curation and procurement. So you need to go and you need to get large sets of data that you can use for training, and then you need to kind of curate that data to clean it up and to make it usable. A lot of time that you will spend in doing machine learning type tasks and AI type tasks is likely going to be on the data portion, because if you don't have good data, you're not going to get good results. Garbage in, garbage out. That's kind of the mantra when it comes to machine learning. And so that in itself can be a very expensive and time-consuming process, just coming up with all of that data that you can then use to train your model. So that's one part of it. The next part then is that you need to go through the actual training phase, which can be very expensive, both from a time and cost standpoint in terms of the amount of hardware that you need to train from scratch, the amount of power and electricity that you need to train from scratch, not only running the hardware itself, but also just running the cooling operations. And a lot of these data centers, a large part of their bill is just from the cooling aspect of it. I mean, unless you're way up north or way down south where it's a lot cooler climate, it's very expensive to deal with all that, the heat aspect of it. And so then the idea then is that you have a company who's gone through all that process in which they've trained their model. When I say train their model, I mean that they give input in and they get a response out. And they look at that response and basically say whether or not that is what they were expecting for a response. So they have an idea of what the expected outcome should be versus when given a certain input. And so then they look at that output and say, it's not correct. This is how it needs to be corrected. And then they attempt to adjust the weights within the model. The weights are basically what controls relationship between data that comes in and the output that's generated out. Those weights are then adjusted, and the process is repeated over and over and over. So now this is typically an automated type process. If we're doing something like supervised learning or even unsupervised learning, really. But usually you're going to have some type of labeled data. And so you have an expectation of what it should look like when it comes out. And adjustments are made in this training period to get that output to match what you expect for a given input. And that can take a lot of time. So now you've got someone who's already done that. They've already gone through that whole process. So then what you can do as an individual who wishes to have your own model that replicates that functionality, you can do what's called a model extraction attack, which is that you take that pre-trained model that's already got all the weights and everything set in it, and then you take input, you send it in, and you get output. Now, you can then take those input-output pairs by saying that when I give the model this input, it gives me this output. You now have data that you can use to train your own model to try to replicate the behavior of that target model. Because you know when you give this data input to the target model, it gives this output. Now you can take that information pairs of input-output information pairs, and you can go and you can train your own model, which is going to be a much faster process and less expensive than training the model from scratch, especially curating and procuring all that data that originally needed to go into that training that original model. And then you'll get what's you can get an exact replicant of the model, or something not quite an exact replicant of the model, because the weights are never going to be the same, but you can replicate the behavior pretty close. And you can oftentimes get what is called a distilled model. So you might train your model on a more specific use case than what the target model was trained on, and you don't need as many weights and parameters as that original target model to be able to do that. And so you have what's called model distillation, which is where you get a model with a smaller footprint that is still functionally equivalent to the target model, at least for your specific purposes, which is a pretty cool kind of side effect of this model extraction attack. And so why does this really matter? Well, you think about it, if someone does this model extraction attack, I mean, your IP has basically become someone else's now, someone else's product. So someone can now take that model that they've built based upon this model extraction attack by using your model, which you likely put more time and money into. They can now take that extracted model that they've created, and now they can sell access to it to other people. So that's one thing, is they can monetize it. And starting from, let's just say, much further into the process with far less investment into the process than the people who built the original model. There's also kind of a security issue, which is that if you're doing this against, when we think about this, we're probably thinking about large language models, but you can also do this against classification-based models. So models, for instance, that are malware classifiers that take programs and look at them, or pieces of code or scripts or whatever, and look at them and try to decide whether or not they're malicious. Now, my dissertation work was actually on this subject, and so that might be why I was a little bit biased towards picking this as a topic to talk about today. But the idea is that if you can, through model extraction attacks, make your own essentially copycat, replicant, surrogate model, however you want to call it, of a classifier model, in particular a malware classifier in this case, now you can start to pick apart how is it actually making the decisions that it is making, so that way you can form your malware knowing and test it against your surrogate model before you test it against the target model. And so that way you can get much quicker feedback in terms of iterating through different malware approaches to get it to bypass the model, test it on your model. So now you know that it works, but you haven't given your final sample to the target model that you're going to try and go after, so that when you go in, it's something that has never seen before, but you know, based upon testing against your model, that likely it's going to bypass the final target model. So there's also a sense of data risk, which is that in some sense, data does, especially with like these large language models, and I mean some other models too, classifier models like facial recognition and other types of models that are out there, is that there is a certain amount of data memorization that gets baked into these models. And so then if you can replicate the functionality or close to functionality of a target model, you can potentially extract out sensitive data that was baked into that model by dealing with your local model rather than dealing with someone else's model. So what makes this process easier or harder for someone to do? So talk about we talk about the attack, which is basically you've got someone else's model that is already up and running, already trained, everything. And you're sending a bunch of queries to it, sending a bunch of data into it, looking at the output, taking those input-output pairs, training your own model. What can make this process harder for people? Well, one of the things is certainly API monitoring and throttling. So you limit the access that people have to be able to send in all this information and get information out they can use to train their own models. Now, that's a tough one, right? Because especially if you're charging access, API access to a model, then you don't want to shoot yourself in the foot from a monetary standpoint, right? I mean, you want people to be using your model a lot. And so that can be a little bit of a difficult one, the API monitoring or the throttling. And so you need to do it in such a way that you can kind of pick out and determine when someone is using this in kind of the normal course of business versus when someone is doing this maliciously or really like an automated fashion of it is very clear that they are just probing for data rather than normal use cases. And that can be easier said than done. That can be kind of a difficult one. But certainly if you do have some kind of monitoring and throttling in place, that can help. You also want to look at the amount of output that you're providing with people and the level of output. So, for instance, providing people with probability scores as output is far more beneficial to them in a model extraction attack than just providing them with labels, such as yes, no, right, wrong, or even in the case of like LLMs. So the way that LLMs will work is they will spit out tokens, or we can just call them words in this case, but really tokens. And it will have a probability associated with each token or word in terms of which one is most likely to come next based upon the words that it has seen previously already. And so rather than provide those actual probability scores that go along with the words, you can provide just the word choices themselves without a potential probability associated with them. That can reduce the amount of information that you're giving to people. If we look at terms of like malware classifiers, providing a probability score there is certainly much more beneficial to someone performing a model extraction attack than just providing yes, it's malware, or no, not detected. We don't think it's malware. We can't say that it's malware versus 70% chance this is malware. Okay, now only 40% chance, now 50% chance, because then people can play games with how they adjust the malware, sending it in, looking at the output and seeing which direction they're moving rather than just a binary choice of good or bad. There's also the concept of watermarking to try to bake some kind of a watermark into the model. Now that's going to be varying degrees of success, basically, of how well that's going to work. Because remember, when you're doing these model extraction attacks, it's unlikely, nearly impossible, that someone is going to come up with a model that has the exact weight values as the target model. And so if you're baking some of these watermarks into there, the chances of those getting replicated within the distilled version of the model that likely comes out from the model extraction attack, that's going to be tough. I mean, if someone just fully steals your model, I mean, they steal all the weights and everything, then yeah, sure. I mean, that approach might work, but otherwise it's going to be, that's going to be a tough one. Another thing that people talk about is differential privacy, which is really used more from model inference attacks, where people will try to extract out sensitive data from models. We talked about that a little bit earlier, but basically they're trying to get out some of that sensitive data that has been baked into the model during the training process. So you can use what's called differential privacy training, or during the training phase, use what's called differential privacy, which is essentially introducing a certain amount of noise into the training data that makes it more difficult to extract out the secret information later, we'll say, or private information later. But the problem with that is that if you go too heavy handed on that, too ham-fisted, if you will, that you can end up degrading model performance, which isn't, that's not great either. So you could have also do things like maybe set up honeypot canaries to try to catch bulk scraping of deploying models out there that are just kind of honeypots to lure people into trying to perform extraction attacks. And you can collect information on those individuals and try to shut them down in other cases when they're going after your big models. But obviously that's not going to be as feasible for companies with like ChatGPT and Anthropic and others that the models are just, it's kind of there. Like we all know where to get the actual models, and they're likely not honeypots. So that's kind of a tough one. So those are just a couple things to think about, though. Certainly that monitoring and throttling, limiting the amount of information that you're outputting, those are going to be the big things. When it comes down to it, overall, it's kind of still a tough problem to solve, because you need to walk that line between security and usability, right? If you're throttling everybody just for normal usage, then obviously they're not going to want to use your product. They're going to go on to one of the other models to use it, and you're going to miss out on that revenue. And so you got to, strike that balance there. So what can you do once you think that you have detected that someone is performing malicious activity and trying to perform a model extraction attack? Well, you can rotate or revoke API keys. Basically just pull their access. That's one thing you can do. Save evidence of potential attacks and potentially try to get legal or your PR team in on the talks earlier rather than later. So then that brings us to a couple questions. And that's, at what point does legitimate benchmarking become model theft? Well, it's kind of at the point where people are using those input-output pairs to then go and try to make their own model, try to make a copycat or surrogate or replicant model, however you like to call it, of your model that you have already trained. That's kind of the point at where this benchmarking really starts to turn into model theft. But so, from kind of more of a philosophical standpoint of what are our thoughts on model theft? What are, is this right or is this wrong? Well, I'm kind of a little bit split on this, because let's think about how most of these models were trained and what they were trained on. So most of these models, these big models, are trained on data that they have collected off of the public internet. And not even just the public internet. We have found cases, there's been legal challenges of models who have been ingesting copyrighted data from other people to be used as training. And so really these models are built upon the ideas and thoughts and works and properties of others that are out there. And that's a whole discussion within itself of right or wrong, one way or another. But let's just keep that in mind when we're talking about these model extraction attacks, especially when we're talking about like the large language model extraction attacks in particular. It's a little bit different for, malware type stuff. But when we're talking about ChatGPT, Claude, Gemini, others who have, basically hoovered up all this information across the web and from all these different people to build their models. Okay, so that model was built upon the works of others. So then is it really that bad to then build your model off of their model that was built upon the works of others? It's kind of a little bit up for debate, right? I don't know exactly where I fall upon it. Certainly there are the concerns of power usage of if they're hosting the infrastructure. But if you're paying for it and you're paying for the API access, then technically you're compensating them for the usage. And so it's kind of a tough question to answer. And where do you draw the line? And should this basically be behavior that is not allowed? And really, what do we consider if they're not, fully stealing the model, they're just kind of basically rebuilding the behavior of the model. Is that really theft of intellectual property? So I'm not a lawyer, I can't say what the laws are, but just food for thought and things to discuss. So key takeaways, basically just know that if your model is accessible out to the public, likely someone's probably trying to copy it. It's probably happening. And you just kind of, if you don't want that to happen, then there are certain measures that you can take to try to stop it, such as monitoring, API rate limiting, and looking for just kind of odd spikes in behavior and other anomalies. But you remember, you got to walk that balance between usability and security, which is the case for most security practices and implementations. So with that, we'll go ahead and close out the episode. I hope that you enjoyed this solo talk on model extraction attacks. And so with that, say take care, and as Joff would say, keep on prompting.